8-3, volume of spheres. Our state standard, I can develop and apply formulas for volumes of spheres. The formula for the volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. That sounds really weird, but guess what? It works. I don't know who founded that and developed it, but kudos to him, so I don't have to. So, find the volume of the sphere to the nearest tenth. Volume equals 4/3 pi r cubed. So, 4/3 pi times 11 cubed. Now notice there's no capital B. That's because spheres don't have a base. Cool. So I'm just going to punch this in my calculator. 4/3, so 4 divided by 3, times pi, times 11 to the third power. And I get that great big long decimal. 5,575, and then a big long decimal. I'm just going to put two places because it says round to the nearest tenth. So 5,575, I lost a 5, and 3/10 meters cubed. That's not a repeating decimal. It just means I rounded to that place. Put your radius in, punch it in your calculator. Here, find the radius if I know the volume. So this one's will work backwards. Volume equals 4/3 pi r cubed. So 2,304 pi equals 4/3 pi r cubed. Well, as I look at that, I realize that both of them have pi's, so I could divide by pi and get rid of that. That would be easy. 2,304 equals 4/3 r cubed. How do I get rid of a fraction coefficient? I multiply by the reciprocal, 3/4. So 3/4 times 2,304 is 1,728. I cube root, and we did those a couple chapters ago. But if you don't remember, we have to put the 3 in first as our index, find our cube root button, 1,728, and we get 12. So 12 equals R, labeled centimeters. So the radius is 12 centimeters. Again, our standard, I can apply that formula and find volume of cones. Now, we're going to backtrack a little bit, and we're going to use a real-life problem. Now, in real life, this happens to be a lovely cylinder and a hemisphere to make our silo. The radius of the silo is 9 feet. So that means that radius is 9. And the overall height is 48. So that means from here to here is 48. So if I want to find volume of the cylinder part, volume is capital BH. Now the base is a circle, pi r squared. So we have pi times 9 squared, 81 pi is our area of the base. So 81 pi times height. Now, is the height of the cylinder 48? No, that's the whole height. So I need to know just the height of the cylinder. Well, what's this distance here of that hemisphere. Well, if the radius is 9, guess what? That radius is 9, which means that this height is 48 minus 9, 39 feet tall. So that's 39. That's the tricky part there. So 81 times 39, and we get 3,159 pi. And I'm going to leave it that way for just a minute. Now I need volume of the hemisphere, which would be 1/2 of 4/3 pi r cubed. Oh my goodness. So 1/2 of 4/3 would be 2/3 pi of radius 9 cubed, which would give me 9 cubed times 2/3, 486 pi. So my total volume would be 3,159 pi plus 486 pi, or 3,645 pi. So 3,006, did I add that right? I hope so. Oh my goodness. 11,451, but rounded to the nearest thousand would be 11,000 cubic feet. Now, if I'm a farmer and I'm putting corn in my silo, that might be something I need to know. Surface area of a sphere. Surface area is 4 pi r squared. 4 pi r squared. And again, we have the radius of our sphere. So if I have a sphere with a radius of, let's say, 5.5 inches, what would my volume be? So volume would be 4 pi times 5 5/10 squared. And guess what? I'm just going to punch that in my calculator. 4 times pi times 5 5/10 squared. And I get 380.13, so to the nearest tenth, 380 1/10 inch cubed. I can apply the formula for volumes of cones, cylinders, spheres, and real-world problems.